Hello, everybody, and welcome back to General Science. We're going to follow up our last episode on plate tectonics with an episode with a little bit more in-depth information about volcanoes. And next episode, we'll talk a little bit about earthquakes before we move on to more environmental science instead of geology. So let's talk about volcanoes. First of all, what is a volcano? That's kind of important. A volcano is basically just a vent that connects the molten rock in the crust all the way to the Earth's surface. So the volcano is made up of several different parts. There's the vent, which is the part that lava comes out of. There's the cone, which is like the mountain which the volcano comes out of. The conduit, which is where the magma flows up to the top of the vent. And then a magma chamber at the bottom where all the lava comes from. So those are all the different parts of a volcano. Why do volcanoes erupt? Well, it's because all that hot rock is buoyant. It has a lower density than the rocks around it. And so it's going to rise up through the crust to try to get to the surface. Basically just because of buoyancy. It's kind of like how water is going to float up, right? Same reason. So when magma reaches the surface, it kind of depends on how it's going to flow, whether it's viscous or not, and how much gas is going to come up is going to depend on how it erupts, right? A large amount of gas and high viscosity is going to form more of an explosive eruption, whereas a small amount of gas or a low viscosity is going to make it more effusive. Okay, so those things are going to make is going to matter to make it erupt in a certain way. So the viscosity of the magma and the amount of gas in the chamber is what's going to determine how it erupts. Explosive eruptions can be super catastrophic. We're talking about tons and tons and tons of cubic kilometers of magma, sending ash clouds 25 kilometers up into the atmosphere, and they can have severe environmental and climatic effects. We're talking about blocking out the sun, causing climate change, all sorts of things. These really large explosive eruptions can do that. And there's three major effects that come out of an explosive eruption. There's the ash fall, so all the ash falling down out of the sky. And then there's also what's called pyroclastic flow and pyroclastic surges. And we're going to talk about what those things are in a little bit, don't you worry. The pyroclastic flow is kind of that big, huge surge of really hot molten rock is pyroclastic flow, and a pyroclastic surge is when a bunch of it comes at fast. You think of it like a landslide, but of magma and hot rock. Okay. Effusive eruptions are going to be the kind of slower, less explosive ones. This is where lava pouring out onto the ground. Okay, you see these a lot in Hawaii or in Iceland, where you can just see trails of lava kind of flowing down like a river. Those are effusive ones. That's where you're going to have that low viscosity, low amount of gas. We spend a lot of time monitoring and trying to mitigate the hazards of volcanoes, especially around places where people live. We're talking about places like Iceland, Hawaii, Vesuvius in Italy, right? Those kinds of volcanoes we monitor constantly. And we do that to kind of avoid the fatalities. Even recently, there have been volcanic eruptions that have caused thousands of people to die. And we're trying to avoid those kinds of things from happening. So we're, as a scientific community, as a worldwide community, we're trying to mitigate these disasters, make them as little fatal as possible. There's a better way to say that, but you know what I mean. So, like I said, there's lots of different hazards from volcanoes, so we're going to go in a little bit more depth of what they all are. Pyroclastic flow is all of the ash and soot and all of that comes down, that hot molten rock, right? That's all pyroclastic flow. Think Pompeii. Okay, that's where you're going to see pyroclastic flow, right? Everything's solidified in rock. That all comes from the pyroclastic flow. Pompeii, of course, that happened in 79 AD in Italy, and it turned the entire city of Pompeii into this stone ash. Pompeii was next to Mount Vesuvius, which is a volcano. Vesuvius today is a hazardous volcano, and it has a lot of people living next to it, so it's one of the volcanoes that we do monitor a lot. Just get down here in my notes. Okay, so how does pyroclastic flow create devastation? Well, for one thing, it's going to be directly impacting this stuff. So it's going to flatten a lot of stuff as it flows quickly down a mountainside, right? Because volcanoes usually are mountainous. But it's also going to bury stuff. Things are going to get buried underneath this large amount of rock and soot and everything like that, like Pompeii, and that's going to also cause damage and devastation. Not to mention all this stuff is hot, so anything in the area that doesn't get buried or flattened is going to get burnt. So that's also not great. Okay. Another dangerous part of a pyroclastic flow is what's called a lahar. And that's when the hot volcanic activity melts snow and ice, and that meltwater might pick up rocks and debris and form these basically fast-moving floods, which can also destroy things. So not only are you looking out for hot lava and rock, but you're also potentially looking out for flash floods and stuff like that when you have these volcanic eruptions. Pyroclastic fall is a little bit different. This is the ash load that's falling down from the sky that just got blown up into the air. And ash load is dangerous because it can collapse roofs and bring down power lines, but it also kills plants and contaminates water supplies. So all those things that people are going to be relying on for oxygen and for water are potentially going to be damaged during pyroclastic fall. Not to mention that all of that ash is not good for you to breathe in. So you don't want to be outside when that's happening. You don't want to be breathing that stuff in. Lava flow is can be hazardous, although effusive lava is less dangerous, but it's not great. It's hot magma flowing down, hot lava. So you don't want to actually be in the way of it, but it's definitely safer than the explosive kinds of volcanoes. Iceland is well known for lava flow, and that's because the entire island of Iceland is created by volcanoes. There's thousands of them there. And so you can actually go and see volcanoes erupt safely from hotels, in Iceland, which is kind of cool. So if you ever want to see a lava flow, you should head there. Or I guess to Hawaii, but it erupts less often there. So Iceland's the place to be for that. How do we mitigate this kind of stuff? Well, we mitigate it by monitoring, like I said. So there are observatories that we set up along volcanoes, and there's lots of different ways that we kind of monitor these volcanoes. We watch for the ground to become deformed, because that happens before volcanoes erupt. We have things set up to measure seismicity, the amount of gas coming from the volcano, how the water is being changed, because that's going to happen, right? The contents of what's dissolved in water around the area is going to change as more gas and rock is starting to heat up and it come out of the volcano. There's lots of different ways that scientists monitor volcanoes to see if anything's changing. So why do we measure seismic activity? Well, it's because earthquakes often precede eruptions. And that's just because magma is pushing up towards the surface, so it's going to be shattering this rock, causing earthquakes. So we make sure that we have seismographs stationed on the flanks of volcanoes so we can measure if there's any kind of seismic activity near the area. We monitor deformation because as the volcano begins to, the lava continues to go up, that's going to change the shape of the mountain around it because it's pushing out the rock. So we want to make sure that the volcano is not deforming at a high rate, because that could indicate that an eruption is going to happen soon. Gas monitoring. Volcanoes increase the amount of gas that's being pushed out of the volcano soon to eruption. So we know what kind of volcanic fumes are out and around there, and so we measure those gases to kind of see what the output is. And so we know what a standard amount is during the year, and then if it increases rapidly, we're like, okay, there's going to be a volcanic eruption soon because there's more gas activity. Are there other volcano-related hazards? Well, yeah, there's noxious gas. which in 1986, an entire town in Cameroon died because noxious gas got released from an underwater volcano. It killed all those people, right? So that's not great. So we want to make sure that we keep an eye on that sort of stuff. Let's see what else we got here. Then, of course, there are the earthquakes that might come from volcanoes, which could lead mountains to fail, avalanches, all that kind of stuff. So those are a dangerous part of volcanoes. So kind of in summary, volcanoes are hazardous, but we study and monitor them, and we try to understand how they work. And in that way, we can help mitigate the disasters and the damage that could happen from them. Thank you so much for watching another episode of General Science. Next time, we're going to take a closer look at earthquakes before we move on to some environmental science study. Thanks again for watching, and I can't wait to learn more science with you next time. See ya.